Hello and welcome along to a recap lesson of straight line. In this lesson we are going to look at a couple of different straight line equations, okay? One's with points that are both positive and negative, some with positive gradients, fractional gradients, negative gradients, infinite gradients, undefined gradients, zero gradients. So really fast forward through the bits that you are familiar with, but this is going to be here so that you can just have a good recap of what has been covered so far. Okay, so find the equation of the line which joins the points negative 2, 4 and 6, 6. So your structure point gradient equation. Okay, so x1, y1, x2, y2, gradient y2 minus y1 x2 minus x1. Okay, so if you're not familiar with this, please watch the videos earlier on. Okay, so 6 minus 4 is 2, 6 minus negative 2, 6 add 2 is 8. Always simplify your fractions. Okay, no matter what age and stage you are, you always simplify your fractions. Okay, you have a choice here. You can either use y equals mx plus c, or you can use y minus b equals m multiplying x minus c. Okay, as you go through your school, this then becomes the equation that's probably most commonly used. Okay, you can choose whichever one you want. So let's choose avoid the negatives. Let's go with a and b. So y minus 6 equals quarter x minus also 6. Okay, so notice that this is our a and this is our b. These are both 6, so it does matter, right? That 6 is that 6. Now at this point we'll multiply through by 4. So 4y minus 24 equals 1. We'll leave that there just now. Minus 6, okay. If you didn't want to leave that 1 there, then you would have had just that written there. Okay, simplify it by collecting like terms. Minus x minus 24 plus 6 is minus 18, and that's equal to 0. Okay, so that's a general equation of a straight line, right? Variations of that, since we're doing a recap, acceptable variations would be 4y minus x equals 18. That's simplified, that's perfectly fine. If you wanted it in the form ax plus by plus c equals 0, then we would have to invert all the signs, so we can multiply all that through by negative 1. So negative 4y plus x plus 18 equals 0, right? Or we can indeed change all the signs by inverting the operation as we go over that equals sign. So x, just writing it in that form, equals 0, so it's in that ax plus by plus c is equal to 0. Okay, so they're all acceptable. 1, 2, 3. Or any other variations, negative x plus 4y is equal to 18, negative x minus 18 is equal to negative 4y, and so on and so forth. Okay, just variations. Most popular, simplifying here or working towards this ax plus by plus c, and again that's quite a popular way of doing that. Okay, so that's the first one. The second one we are going to look at, so you can just fast forward this wee bit, I'll just keep going. B is 5 and 0. And negative 1 and 12. Okay, so again, structure, point, gradient equation. So our points 5 and 0, negative 1 and 12. If you are doing this, can you double check that you have written them down exactly the same? Okay, you don't want to start with a transcription error, right, by getting these numbers round the wrong way. So our gradient, 12 minus 0, negative 1 minus 5, 12, negative 6. So our gradient, 12 divided by 6 is 2. So 12 divided by negative 6 is negative 2. Okay, so a negative gradient. So this line is a steep line. It's gradient negative 2 going down from left to right. Y minus b m times x minus a. Okay, again, you've got a choice. What's your a and b going to be? 5 and 0 or negative 1 and 12? We'll go for this one, right? So y minus 0, negative 2 multiplying x minus 5. Okay, take a wee check if that's correct. B is 0, a is 5. Okay, the signs are as they are. So y minus 0, just y. We could leave it like that, right? Tendency is we want to multiply it out in case we're then asked to do something with the gradient, okay, or we're asked to do something else. So perfectly suitable answer for that one. Okay, y plus 2x minus 10 equals 0. So the variations and the answers. Okay, ax plus by plus c equal to 0. Okay, so just the variations that you could get asked. Or if it was a question, show that in the form. Alright. Okay, so C down here, we've got negative 3, 6 and negative 3, 5. Okay, so when you're doing equations of straight lines, look at the coordinate points initially, right? Have a look at these ones. By inspection, what can you tell from that, right? Should we draw a diagram? A quick sketch. Negative 3, 6, negative 3, 6, negative 3, 5. Oh, look at that. Negative 3, so we have a vertical line. What do you know about that vertical line? Well, all the x values are going to be the same. All the x values are going to be negative 3. Right, so don't be alarmed if you go through this process and you don't get this ax plus by plus c equals 0, because these are slant lines. Okay, but you have also your vertical lines and your horizontal lines. Okay, so let's say you didn't notice that and you went through the motions of your structure. Right, your gradient. So 5 minus 6, negative 3 minus negative 3. Right, negative 3 minus negative 3, but 0. 5 minus 6 is minus 1, so your gradient is what's that going to be? It's going to be infinite. Can you divide by 0? Right, it's undefined. Okay, if you've done that in a calculator, math error, undefined. Okay, so you, at that point, you should know that's a vertical line. Okay, so the equation would relate back to all the x values. Okay, being the same, which is, in this case, x equals -3. Okay, so that's a vertical line. Okay, so question D, for the recap. This one, what do you think? What do you think this one will work out? First one we had a fractional gradient which was positive, second one was negative, the third one was undefined. What about this one? Right, let's see if we can have a look at it by inspection. Have a wee look at it. What's going on with that? Quick sketch. 5 and 2, 3 and 2. What can you tell me about that? Horizontal line. What do you know about that horizontal line? All the y values are equal to 2. Now I know it's a horizontal line and the x-axis is a horizontal line, then why is it equal to, why is equal to 2? It's always something we get asked, but really it's about the positioning. Okay, all the y values on that line are equal to 2. The x always changes. Right, that's a fixed point, but this, the x is varying, the y value is fixed. Okay, so if we were to go through the motions, doing this as a question, you didn't notice that to begin with, you can save yourself a lot of working if you do notice things. Right, maths is about noticing as well as doing all this working and calculations. So 2 minus 2 and 3 minus 5. 2 minus 2 is 0, 3 minus 5 is -2. Okay, and 0 dividing by anything is 0. I can't do anything else with that, so that's equal to 0. So the gradient's 0. So you probably think at that point, yeah, we're okay, we'll keep going with the equation. So y minus b times x minus a. What will we choose? We'll just choose a lower number here, the 3. Maybe prefer to work with the 5. B value is equal to 2 either way. Gradient 0. Well, 0 multiplying anything, whether it's the 3 or the 5, will be 0. Okay, valid equation, right? Tendency is to write it like that. Okay, so really there are 4 different types. Okay, positive, fractions, negatives, 0 gradients, undefined gradients. If we were to think about a summary for this so far, then what do you need to know to find the equation of a straight line? Minimum, point, and a gradient. Right, if you don't have a point, do you have 2 points? Okay, so sometimes you're given a point in the gradient, sometimes you have to do something with it. Right, I'll come later on. You know your gradient. y2 minus y1, x2 minus x1. Okay. What else do you know? Gradient is also the vertical over a horizontal. Okay. What else do you know? Positive gradients go up from left to right. Negative gradients go down from left to right. No gradient. Undefined gradient. Okay, so definitely have a good viewing of this, right? Go over it, go over it, and go over it. Bottom line, equation of a straight line. Be familiar with y equals mx plus c. Be familiar with y minus b equals m times x minus a. and be familiar with this general equation of a straight line and variations of that. Okay. Right, thanks for watching.